All right. Hello, everyone. I am August Brzezinski, and presenting with me today is Benjamin Morris. Today, we'll be talking about the eye tracking from senior design.
So just a little info about our sponsor. Bonita Sharif was our sponsor. She's a professor here in the Department of Computer Science and Engineering. Uh, she also does software engineering research, and she's a member of some empirical studies group. Her research areas, she specializes in software engineering, program comprehension, eye tracking, empirical studies, human-computer interaction, software traceability, and emotional awareness in development.
Kind of some stakeholders in our project were operational for the most part is Dr. Sharif, and then Cole Peterson, which is her research assistant. And then since this is a project that we are working on developing a tool for technical interviewers, and as well as eye tracking researchers. Some businesses would be some eye tracking companies that build cameras like Smart Eye, Tobii, and iTrace, as well as software companies holding technical interviews, as well as just the general programming population and potential interviewers and employees.
Our team is August Brzezinski. He's product manager and squad lead. He also played a big role in the web development. I'm Ben Morris. I was the development manager. I was also kind of in charge of the web development. Mike Senior, he did a lot of work with Adam and Core. Alex Sokolov, he was also another web developer. And then David Gao, he kind of just helped us wherever we needed it, and he specialized in the database.
So yeah, kind of the problem and opportunity that we were given to this project is kind of two big things right off the bat, where eye tracking data is difficult to digest and existing visualizations don't provide much insight into the exact problem that we're trying to answer with developing a tool to help with interviewers with technical questions. So I have two pictures kind of on this slide, which are two sort of existing visualizations. The one on the right is more of a heat map style, which is really good at showing what sections of code a user would look at a lot. But a downside with that is that there's not a lot of information about timing. So you're not entirely sure where the user started, where they ended. And so that's kind of lost. And then in the bottom is another sort of example of an eye tracking data collection, which has a little bit more information about timing. But as you can see, it gets very clustered. And once everything starts overlapping, and if this was on a longer file, it would get very difficult to understand very quickly. So kind of with that, and then the idea that a lot of technical interviewers right now rely on sort of live explanations of what the user is doing. We were given a great opportunity to invent a tool that would allow for someone to do a technical interview, be told, hey, look over this code and analyze it. And then after, tell me and understand it. So then we can use this new eye tracking visualization that we were set out to develop to allow that interviewer, after the interviewee is done studying the code and then explaining it, to see how they would look over certain amounts of code. So then they could see like, okay, so he looked at this for loop and then went on to look at what, and kind of be able to understand the thought process. And then kind of with that, developing a new visualization would kind of help revolutionize the field of empirical software engineering.
Yeah, so now we're going to discuss the solution built. There are really three main parts to this system. We have CoderGaze Core, CoderGaze Atom, and CoderGaze Web. I'll just start off with Core. This is our core tracking app, and this handles interfacing with the eye trackers, and it sends data to the Atom plugin, and it combines and fixates data. I think Gus will talk about it a little bit. And then CoderGaze Atom. So this is our text editor plugin that connects to Core, and it collects data about the source code that we're looking at. It translates position data for combining with core data. And then we have CoderGaze Web, which is our web application, And this is used for parsing and interpretation of the data. And then it also displays the visualization that we built.
So moving on from there, we're going to kind of go over highlights. So starting off with Core and Atom, a lot of this was built by previous year's team as kind of like the groundwork for where we got to start off. So some of the improvements that we made upon that are on Core, we implemented the new type of camera, which is the Smart Eye Tracker, which allows for a lot more data collection. So hopefully in the future, there will be able to add on with the Smart Eye data to improve visualizations. There's also some problems with some of the tracker functionality. So we did some improvement on that. And then another big thing that we added to Core was data processing, mainly in the form of something called a fixation filter. Basically, this is very important for the way that we study it, because if you're looking at a Word document, for example, I guess it's a good place to start. If you look straight up and down on it, so if you look at the first line and then you focus on the 10th line, an eye tracking camera would get a lot of data. You would get a lot of data at the first line, and then data at the 10th line, and then some data in between. That is basically your eyes transitioning from a fixation to another fixation. And what a fixation filter allows us to do is look at the point A and look at the point B and filter out the data in the middle to allow us to get more accurate data results when we go to make visualizations. And then with our Atom plugin, which plays very much hand in hand with how Core works, we did some code recognition improvements. There were some bug fixes that we had to make with newer versions of Atom. So we had to downgrade a couple of things just to keep them working. And then another important thing that we implemented on Atom is something called SourceML, which takes source code files and parses them into an XML format that gives a lot of information about like what a certain token is. So like the word for has a lot of information tied to it, saying it's in a loop. And what was that? And as you can see on our right, kind of is a graph of kind of our flow process for our program. So as you can see, you start coder gaze, you set an output directory. If you're using an eye tracking camera, you calibrate. We have mouse as well implemented just for testing. And then along with that, we start tracking with Core, start tracking with Atom, collect our data, stop tracking. All of our data gets exported. We do our data processing, and then that goes into the website.
Yep. So our web app was built using Vue.js, D3, and Prism. And like we've been discussing, the whole goal of our web app was just to create a new type of visualization for eye tracking data. And the reason we chose this stack is just because Vue allows for super modular development. Like any other team should be able to pick up right where we left off and know what's going on and being able to add features pretty easily.
So just since the web app was our biggest focus, I'll go over some kind of components that we added very quickly. So this is our main screen. As you can see on the left here, we have the source code view, and on the right, we have our graph that we have been working with this year. We use a system that we've called our nodes and transition system. So the nodes are big circles. They represent a token text, and size would represent how long a user looked at. They have numbers next to them, which would represent the order that the user looked at things in. So you can see that this middle node has 4, 9, 10, 12, 13, 14, so on and so forth. And a little bit more south is 3, 2. So you can see the arrows that it goes 2, 3, 4. And when you hover over a node, it'll highlight a line on this over to the left. And then when you click on it, it'll allow the user to show more information, what the token value is and what the SourceML tags are. And then we also have a function to toggle off the indices, because when all of the data is showed, it can get a little clustered with all the numbers. And then as well as that, if a interviewer wants to focus on only a certain time frame, there is that on the left side, and you can filter by seconds. So right now this is looking at 21 to 42 seconds. And lastly, we have SourceML implementation as this. So we can look at those tagged with SourceML. And as you can see here, if we add name and declaration to this box, you can look at, it highlights what nodes would have the name SourceML tag tied to it, as well as this orange highlighting would show that this is a name of an item that is also a declaration of the variable.
As for the value, our goal was to set out and create a new type of visualization for our sponsor. I think we definitely did that. There was some key learnings along the way, learning how to deal with deliverables, planning scope, keeping up with the project vision, just dividing work well, and having communication with our sponsor, making sure that we're on the right track. I think that's all.
Thank you, everyone.